Hi, everybody. Our session today, we will continue explaining the population growth patterns. Now, consider a room, a small room or middle-sized room. Okay? If I would have asked you, how many people can we fit in this room comfortably? Let's consider the size of your classroom. Okay? You will answer me. You'll answer me maybe 20. Okay? Then I will ask you again, can we fit 50 people inside that room comfortably? You will say absolutely no. So the carrying capacity of your classroom is 20 people. And this is what carrying capacity. The carrying capacity of an environment is the maximum number of individuals of a particular species that the environment can normally and consistently support. So, in nature, consider the grasshoppers. The grasshoppers feed normally on meadow grasses. So, if the fire burned part of that meadow, the food resource will be diminished and the carrying capacity declines. But if years go by without any diminishing, rain plentiful, the meadow grasses flourishes, so the carrying capacity rises. So the actual size of the population usually is higher or lower than the carrying capacity. So populations will rise and fall according to the environment resources. Okay. Now, if this happen, we will face population crash. So population crash is a dramatic decline in the size of population. See, dramatic decline in the size of a population over a short period of time. And this can happen because of many reasons. Okay? Many reasons can cause population crash. Okay. Now, we have an example. In 1944, 29 reindeer were introduced into St. Matthew Island off the coast of Alaska. At the time of the introduction, the entire island was covered with rich mat of lichens. Plenty of good food allowed the reindeer herd to grow at an exponential rate. By the summer of 1963, the island population had grown to 6,000 reindeers. Good. However, over the winter, large amount of snow fell on food resources, and this caused the depletion of huge numbers of the reindeer. They declined to a number of 50 reindeer remained. Okay, so this is a population growth. The crash. The population crash is limited, limited resources, cause limiting resources, the harsh winter and the scarcity of food. So, what happened that when the winter came and the winter was harsh, so the mat of lichens covered with snow. Now the reindeers cannot eat, and that's why their number declined greatly. We can call that their population number crashed. From 6,000 reindeer, only 50 remained. This is what population crash is. Now, we have also another ecological factors that limit population growth. Okay, so let's say you are hungry and you do not eat rice, and in your household only rice are presented. What will happen to you? your growth will be limited. Why? Because you are not eating, you do not like rice. So you get thinner and thinner and thinner until you reach a dangerous level. Okay? Health will decline. Now, in this scenario, the rice is actually the limiting factor. So, the factor that has the greatest effect in keeping down the size of population is the limiting factor. Okay? Limiting factor is categorized by two parameters: density dependent and density independent limiting factors. So, density dependent limiting factors. Limiting factors that are affected by numbers of individuals in a given area. Example of that: competition, predation, parasitism and disease. This is the density dependent limiting factor. It means how much do we have in numbers in any given population. Competition: the members of population will compete with each other for the food resource or shelter, and this will limit the population. For example, let's consider lions in the savannah in Africa. Lions will always compete over territory. That's why the numbers of lions are limited, and this is density dependent limiting factor. Predation: the population of predator can be limited by the available prey, and the population of the prey can be limited by being caught for food. So, example of that: as the moose population grows, so does the wolf population. But at a certain point, the wolves eat so many moose that there are not enough left to feed all the wolves. As the result of this, the wolf will decrease in population. Okay? This is the book example. Let me give you another example. Foxes and rabbits. Sorry. Foxes and rabbits. As long as there's a lot of meadow grass, the rabbits will keep growing in numbers. And if the rabbits keep growing in numbers, then the fox keep growing in numbers. Why? Because the fox will hunt the rabbit, and there's a lot of meadow grass, so there's a lot of rabbits, so there's a lot of foxes. But if the numbers of rabbits decline, then the numbers of foxes will be declined. And this is predation, another factor, density dependent limiting factors. Parasitism and disease. Parasites and disease can spread more quickly through a dense population, and this is what we are witnessing now in the corona epidemic. Okay? Notice in any World Health Organization report, the huge number of infected people are in high density regions. Like Tokyo, 38 million people there. Istanbul, 20 million people. London, 9 million people. So, in any high density area, parasites and disease can be a limiting factor. Now, the other parameter is density independent limiting factor. So, we explained density dependent. Now, we will explain density independent limiting factors. And these are the aspects of the environment that limit a population growth, regardless of the density of the population. So here, it relates majorly with entangled with the environment. and the unusual weather, natural disasters, human activities. So it the population growth here affected by the environment regardless. The density of the population here is not relevant in any way. So, unusual weather. If the weather changes in like not normal way, it will affect the ecosystem one way or another. For example, in the United States, a lake of southerly winds can prevent nutrient poor warm water from being replaced. Okay? So, the lack of nutrients in the water along the coast can prevent phytoplankton, which form the base of the marine ecosystem. The phytoplankton will be prevented from growing in their usual large numbers. As a result, the zooplankton, tiny organisms that feed the phytoplankton, have smaller population. The effect will be felt later on with smaller populations of fish and birds. And this is the unusual weather. Another example, let's say in Africa, in the savannah, let's consider that normally we have one drought season. Let's say we are facing now 3 drought seasons. What will happen to the populations over there? Population of many species over there. So the number of lions will decline because of the drought. The number of wildebeest feeding in that area will decline. Okay, so because of that, the number of zebra population will decline, giraffe will decline, elephants, hippos, and even the crocodiles, because there are no more populations of any animals that they can eat. And this is the unusual weather. Natural disasters. Also, it's understood the volcanoes, tsunamis, tornadoes, and hurricanes, they can wipe out a whole population, regardless of densities. If a volcano hit, let's say, a huge city with 30 million people in it, this volcano will wipe out all of them, regardless. So the large wave of, another example, large wave of tsunami, okay, can damage fragile coral reefs, knocking down entire mangrove forests and destroy sea turtle nesting beaches. So this can lead to extinction of this species. Human activities. Destruction of wetland habitat along the Platte River in Nebraska. This is another example. My students, we need to take responsibility as a human race because our activities are destroying the environment. We are introducing non-native species, okay, to a different rural and forest and ecosystems. And this is wrong. We are affecting the biodiversity of the ecosystem. And we are also polluting the forests, the rivers, and this can lead to a limiting factor, but density independent. Thank you. We're done with our session today. I hope you enjoyed. See you next session. Goodbye.